Here our goal is to practice a couple of the trig problems like the ones that you'll see in homework. So our first example 4, we are to use the tangent of a sum formula. So let's think what we want to write here. Have your resource sheet handy. You do not have to have this formula memorized. So we want the tangent of the first angle plus the tangent of the second angle, all divided by 1 minus the product of the tangents of those angles. Well, notice, of course, that we don't know the tangent of x, but we do know the tangent of pi over 4. The tangent of pi over 4 is 1. So once we replace that, then we've got a function where the identity is expressed as a single value of that function. Now, there's one more trick that you might do here, and that would be to look to see if you can find any identities if you saw a Pythagorean identity, for example. So if instead of 1 plus tangent squared, if that said 1 plus tangent squared of x, then you might need to replace with a Pythagorean identity. Okay, then let's do this longer problem. We did one like this in class. So we've got some information that's given for 2 different angles. So notice we know the cosine of angle S is negative 1/4 and the sine of angle T. So these are 2 different angles. And for this problem, it says that S and T are each in quadrant 2. So we've got 2 different angles. And if we are only given the cosine, then we've got to take a detour first to find out what the sine of this angle is. So we want to do cosine squared plus sine squared is equal to 1. So we're going to put negative 1/4 in for the cosine and square it. And I hope that you can skip much of this work now. 1 minus 1/16 is 15 over 16. So when we take the square root, because we are in quadrant 2, remember we're given to be in quadrant 2, I'm going to keep a positive value for sine. So we would get the square root of 15 over 4 for the sine of that angle. And now let's work on our other angle. We know the sine of t, but we better find the cosine of t. And this one, when I see 3 over 5 for a sine value, 3 over 5 for a sine value makes me think of a 3, 4, 5 triangle. So I suspect this one's going to turn out to be even easier. So we go to our Pythagorean identity, or you could do Pythagorean theorem. So here we're going to have cosine squared of t, but we're going to put 3/5 in for sine and square it. And again, you've seen this all several times now. So we would move the 9/25 to the other side, and we would have 16 over 25. And then we would take the square root, and we would make this one negative because, again, quadrant 2. If an angle is in quadrant 2, then its cosine must be negative. So now we've got the 4 values. Now we've got our 4 values that we need to find the sine of the 2 angles put together. So remember what we're doing now. We know that angle S is some angle in quadrant 2, and we know that angle T is some angle in quadrant 2. Well, what happens if we add those 2 angles? Once we rotate, what if we ended at S and then we rotated to find angle T added onto it, so we end up with a bigger angle when we put 2 angles next to each other by addition. Okay, so that's what we're doing. Part A, now we want to find the sine of the sum of these angles. So I've pasted in our formula for the sine of the sum. So now we just need to take our values. We're using S and t for our two angles. So we want the sine of angle S, and we found that up above. That is the square root of 15 over 4 times the cosine of angle T, and the cosine of angle T is negative 4 over 5, plus the cosine of our first angle. The cosine of S is negative 1/4 times the sine of our second angle, and the sine of angle T is 3/5. So let me use the parentheses here as an easier notation. And now we've got to do some arithmetic to clean this up. So we'll have negative 4 square root of 15 over 20 plus negative 3 over 20. We have our common denominator, so we can put these together, and notice that they're both negative, so you don't have to, but you could factor that negative out in front. The reason I like to see that negative factored out in front is so that now you realize that the sine of our new angle turned out to be negative. Remember that. We'll come back to that in part C. So this is our answer for part A, the sine of the sum of these two angles. And now for part B, we're asked to find the tangent of the sum of those two angles. Okay, so now I've pasted in what we need to do. For part B, we need to find the tangent of a sum. So this is the formula we want to plug into. Of course, our angles aren't called A and B, they're called S and T, but it is exactly this formula that we need to plug into. So this time we're going to have to take a little detour first, because we know the sines and cosines of these angles, but we've got to think about the tangents. So I'm going to pause the video just for a second and copy what we knew from up above. Okay, so I've simply copied here so that it's in our screen. These were the values. The first two were given to us, and the second two we found by Pythagorean identities. So if we know the sine and the cosine of an angle, then don't we know its tangent? Because tangent is the ratio of sine over cosine. So if we want to find the tangent of angle S, we will get the square root of 15 over 4 divided by the cosine, negative 1 over 4. And of course the fourths are going to cancel. So our tangent of angle S will be negative square root of 15. And then let's do our tangent of angle T. Our tangent of angle T, by the same logic, will be the sine of T, 3/5, divided by the cosine of T, negative 4/5. And again, those 5s will cancel. So our tangent of angle T will be negative 3 over 4. And these are values that we're going to need to plug into our tangent of a sum formula. So now we're in business. Let's go back and see what happens here. So we're ready to find the tangent of our two angles added together is the tangent of the first angle, negative square root of 15, plus the tangent of our second, negative 3/4, divided by 1 minus the product of our two tangents. And the biggest part of these problems is the arithmetic and cleaning this up. So in our numerator, and you might just turn this around. So I'd like to have this constant first, it's negative, and this square root. You don't have to reverse those, of course. And our denominator is negative because we multiply these two become positive, but we're still subtracting. So we have 3 square root of 15 over 4. And you could do this in two separate steps to clean this up. The first thing I notice is fractions inside of a fraction. So to remove the complexity, I'm going to multiply through by 4. So when we distribute to this term, the 4's cancel. So we'll have a -3. And we distribute times this term. And we distribute down here to get a 4. And these two, the 4's cancel. And now we're almost happy with that. I don't mind having the square root in the denominator, but again, that answer isn't going to show up in your textbook. So how do we rationalize when it looks like a binomial? The trick is to multiply by the conjugate. When it looks like a binomial, the trick works because when we FOIL, the outside and the inside combination are opposites and they cancel. So when we FOIL these two conjugates in the denominator, we'll get 16 for the product of the first terms minus 9 times 15 for the product of the second terms. In the numerator, they are not conjugates, so we've got to go through the entire distribution. Remember that FOIL is really just each term multiplied by the next. So let me remind you of that. -3 times 4. The outside product would be -9 square root of 15. The inside product is distributing these two terms, -16 square root of 15. And our last product would be a -12 times 15, since squaring a square root gives us a 15. So we're almost there. A little patience and you'll do fine. You can use your calculator to do some of this arithmetic. So this is a -12 and this is a -180. So we have -192. And two negative like terms here. We've got a -25 times the square root of 16. And in our denominator, we have a 16 minus a 135. So that should give us a -119. If my arithmetic is right, you can check that out with a calculator. Notice all three of these are negative terms. So one more thing I would do here, I would factor and divide out a negative. So we would come up with this answer. You can split this up into two fractions if you want to put each part over 119. But notice, because all of these are negative, bring a negative out of the numerator, bring a negative out of the denominator, and then those would cancel. That's all I was doing here. So there's our answer. Remember what we were finding? This was the tangent of the two angles added together. And notice what happened is that our tangent, so to answer part C, notice that the tangent of s plus t turned out to be positive, greater than 0. Let's go back and look at our answer for sine. In part B, our sine up here, or in part A rather, our sine turned out to be a negative number. So our sine of these two angles put together was negative. So now let's think about a quadrant. Where is the sine negative but the tangent positive? That turns out to be quadrant 4. So the sum of our two angles. So we started with an angle S, and then we added on to that an angle T. So our final angle, S plus T, our final angle turns out to lie in quadrant 4.